Right, we're on. So I thought this was really funny. Look, so I reckon that we might have a chance to see the Northern Lights tonight. Good old Southern England. Apparently, it's already happened several times, but for some reason, I didn't get to hear about that. So here we go. Northern Lights tonight. How to see aurora caused by a rare. This is the bit. Backwards sunspot. A recent coronal mass ejection event may trigger a stunning auroral display. Stunning, I tell you. Simply fucking stunning. Excuse me. A giant solar flare released by an exploding reverse polarity or backwards sunspot is likely to trigger breathtaking auroras in the northern hemisphere tonight. So, first problem is what is a reverse polarity or backwards sunspot? Never heard of that one before, but it gets funnier because they tell you what it is. The sunspot AR3296, which I don't think has got Masonic connections or whatever, but you never know. I'm not a fucking numerologist. It could well be. I don't know, 9/11 seems to loom out. Anyhow, so AR3296 exploded at 11 p.m. on the 7th of May, creating a CME, otherwise known as a coronal mass ejection, that sent highly energetic particles hurtling towards the Earth at speeds exceeding 1,000 kilometers a second. This event is similar, though not quite on the same scale, as the geomagnetic storm that hit Earth in late April, which caused the Northern Lights to be visible across the UK and US. Right, that's the fucking first I've heard of that thing. But there you go. Doesn't mean it didn't happen. Just didn't see it. Or anyone that see it. I'll continue. When these particles slam into the atoms and molecules in the make-believe Earth atmosphere, I like that one, they exchange energy, resulting in the atmosphere being put into an excited state. Oh, really? It is this exchange of energy that creates the characteristic ghostly green waves of the aurora. Now, I have a problem with that because I was under the impression that it's the interaction of the alleged particles with oxygen molecules, even though an oxygen molecule doesn't exist. No, sorry, an air molecule doesn't actually exist. So anyhow, but it's because of oxygen within that air that gets excited that goes green. That's what they say. And the other colours represent other things. Allegedly. So we have our ghostly green waves of aurora. How to see the Northern Lights tonight? The Northern Lights may be visible tonight. Ooh, the 13th of May across the UK and the US. However, the aurora is not guaranteed in all locations. So it's gone from a dead cert amazing thing to maybe. It's just maybe. Fair enough. So, according to the Met Office, there is a chance of a moderate to strong geomagnetic storms tonight, with the aurora possibly visible as far as southern England this week. Oh, they said the 13th specifically. That's today. Predictions made by the Space Weather Prediction Center in the US suggest that midnight tonight may hold the best chance of viewing the aurora for those of us in the UK. That's me, and south. No one knows for certain when and where the aurora will be seen. It's one of the joys of aurora hunting. Here we go. Just as a bird watcher, otherwise known as a twitcher, may spend days, weeks, months, or even years searching for a sighting of a rare creature, i.e. a bird, being a bird watcher. Aurora hunting takes time and patience, says Dr. Alan Wood, the guy who does it, a lecturer in space weather and space systems engineering at the University of Birmingham. See, now I've got a remedy for that, right? Because it's not as difficult as you may think. All you've got to do is go to fucking Norway, right? And the chances are you're going to see it, right? It's Norway. It's where it happens in general. It's obvious. It's not bird watching. Using equipment based in Lancaster and northern Scotland, miles apart, the Aurora Watch Project website displays when geomagnetic activity is above average, or light flashes, which is above average, blip, blip, which increases your chances of seeing the northern lights. Oh, above average activity increases the chances. Well, that makes sense, doesn't it? It's about the only thing that does so far. Wood says, if you're looking for the aurora, you'll need a clear night. Oh, well, yeah, that makes sense again. Brilliant. So, you'll need a clear night, go out of town, away from any bright sources of light. So, obviously at night, not in the daytime. The sun is a bit bright. Give your eyes time, maybe 10 minutes, to adjust to the darkness. Yes. Okay. Start by looking north. It's a good idea. Yeah, northern lights, look north. That makes sense. This is where the aurora is, most likely, to be seen. Well, why the fuck don't you go there then and look for it? North. But don't forget to look straight up too, i.e. otherwise known as your zenith. People naturally scan the horizon and sometimes miss beautiful sights by not looking above their heads. And what I said earlier, it's not what's being missed above their heads where they should be looking. It is what's right in fucking front of them. That's what they're not seeing because they're not looking at it. The aurora has fascinated people for centuries. Oh, whether you see a spectacular display or just a green glow in the sky, it is always a sight to behold. Happy hunting. Hold on, another paragraph. What is a sunspot? Here we go. Sunspots are regions where the sun's magnetic field is particularly intense. They appear dark because they're cooler than the surrounding region of the sun. It don't make sense. They're not cold though. They are still around 3,500 degrees centigrade. Oh yeah, that's not cold at all. It's just that they are cooler than the surroundings, says Wood. So if you're looking at it through some kind of instrument, i.e. a telescope, that's what it's going to look like. Whether or not that actually means that's what it is a different matter, isn't it, for sure. The surface of the sun rotates at different rates in different places. What like? It rotates different from England as opposed to America, maybe. Its surface, that is. Yeah, okay. As a result, the sun's magnetic field becomes twisted. Instead of people studying it, when it becomes more twisted, we see more. Yep, that makes sense. Sunspots, and we are more likely to get space weather events. Okay, more activity, more sunspots. Yeah, that makes sense. One of the most beautiful of all space weather effects is the aurora, also known, here we go, as the northern lights. Well, I'll be darned. So that's what the northern lights are. I wondered what they attributed that name to. Now I know. Right, this is the biggie. reverse polarity sunspots are relatively rare. Yeah, I'll say so. I think you just made it up, mate. Definitely. Making up to just 3% of those observed. And they are watching all the fucking time at whatever it is they're doing. And have a magnetic field that is backwards in comparison to other sunspots found in the same hemisphere. Now, okay, reverse polarity. So reverse polarity of a magnet, it's got to be, isn't it? It pushes away. It's not attracting. It pushes away. So a reverse sunspot is going in the opposite direction to a normal sunspot, which would be into the sun, wouldn't it? That's what they're describing. Reverse polarity of a magnet. Right, so first of all, you've got to realise that only man-made magnets have a north and south pole, because that's how you make them. You pass high voltage through a piece of iron, for example, and that determines the field, north and south. Right, that's a fact. That's how magnets are made. Now, there is nothing on Earth, as in natural, that displays exactly that effect other than a man-made magnet. Right, the north and south pole of the Earth are not a physical thing and never have been. Right, sometimes they say there's God knows how many north poles, 11 or 7, something ridiculous. South pole they try not to talk about because, you know, compasses don't work, geo fucking positioning don't work. Right, when you look at the magnetic field lines of a map of the Earth's land magnetics, it's incoherent. It doesn't suggest anywhere has got a stronger point of magnetic attraction. And there's never been a proven fucking discovery of like a two-pole Earth with a south repelling and a north. Right? It's never been done, not even lodestone, magnetite, iron ore, whatever you want to call it, doesn't exhibit the features of a man-made magnet. It's just a bit attractive, so you can attract it with a magnet. Or you might be able to pick up a fucking paperclip if you're lucky. So along them sort of lines. Which is a joke, really, because so much stuff is based on magnetics and electromagnetics. You know, some people basically say it's what the whole world is made of. And if it weren't for that, there wouldn't be anything. You know, electric universe, although they do fucking great stuff, yeah, I'm not going to dispute that, but, you know, the underlying fucking mechanism is sketchy at far. It's sketchy, isn't it? Because, you know, you've only got to look at how the Earth's axis was established, right, to give its tilt, to give its seasons, right, and within, you know, not long of researching it, what you come to discover is, well, it's an imaginary line drawn from north, what they call north, to south, on a picture of a fucking globe Earth, right, and that represents the axis tilted at 23 degrees or whatever, you know, because it fits. It goes with the rest of the story. Yeah, so we call that an axis. You know, even though something was a ball in shape, how can you tilt it? It's impossible. You can only tilt it if you want to call this bit one end and this the other end. And put a line through it. So anyhow, here's what we have, like the last paragraph, just to convince us that what we've just read is actually real. This is about the guy who's done it all. Alan is a lecturer in space weather and space systems engineering AD is part, it should be and I think, and is part of the Space Environment and Radio Engineering Group in the School of Engineering, in short known as Serene, Serene. His work has been published in journals, so here I'm expecting to read about his experiments and his variables. You know, did he do it with the scientific method approach? Properly, in other words. So this is his work that's been published in journals, including, right? So Alan is a member of the Space Environment and Radio Engineering Group in the School of Engineering. His work has been published in journals including Advances in Space Research, Space Science Reviews, and Geophysical Research Letters. So, where's the difficulty in any of that? Okay? I'm lost here, right? Space Science Reviews. Well, that's not published work, is it? When you use a term like published work, he's had work published. Yeah, they kind of, that gives you the impression that he's done something that says he's quite a clever fella and he knows what he's talking about. Even though peer review and all that is a fucking scam, it don't matter. But that's how it goes. But he's done nothing. He's done some reviews and wrote a letter about geophysical research letters. So he wrote a letter to someone saying, oh yeah, I've been doing geophysical research. I just thought I'd let you know. It doesn't say what he was researching, whether he was researching anything. It's just bollocks, isn't it? But I guarantee 8 out of 10 people that read this will go, oh wow, he must be clever. Oh man, look, he's been published. I wouldn't publish him in the fucking Sun. Literally. Let alone anywhere else. Excellent, brilliant. Well, I just thought it's funny as fuck, isn't it? You never know what's going to happen next. Later.